A total eclipse of the sun. Understand it, predict it by building this Earth, Moon and Sun Orbiter, a precision brass model that demonstrates the complex relationship that governs life itself, like the seasons and the phases of the moon. Build it step by step with this inspiring magazine, the Earth, Moon and Sun Orbiter.
Have you ever seen a Tellurion? What is it and what does it do? For first of all, it shows the movements of the Earth, Sun and Moon very accurately, and this is a precision instrument. All the gears are very carefully made, and as you can see, they're all made of brass. And this will predict eclipses and show you just how these three bodies behave. It's also highly decorative, and you can build it yourself. There are instructions here in the magazine, and you can build it by even by anyone as ham-handed as I was. And if you do, I think it will give you hours of enjoyment. So I'm very impressed with this Tellurion.
Hi, I'm Calmels, and I designed the Earth, Moon and Sun Orbiter, or Tellurion as it's also called. It can be used to predict solar and lunar eclipses and to demonstrate the rotation and orbits of the Earth and Moon. Made mainly in brass, it's a beautiful, precision-engineered model of our home planetary system, as well as a practical and accurate scientific tool. Its development involved painstaking research, and it includes many design firsts for a model Tellurion. You can observe the accurate daily rotation of the Earth, demonstrating day and night. You can see how the Earth's axis is fixed in space, and how this influences the changing seasons. Follow the Moon's orbit around the Earth. See how the Moon's orbit is inclined at 5 degrees, and rises and falls on an inclined track, and how the precession of the Moon's axis is accounted for by rotating the inclined track. You can also observe the rotation of the Sun, and how the Earth and Moon system rotate around the Sun. There's a resettable year counter and an indicator for the elliptical orbit of the Moon to demonstrate the Anomalistic month, allowing the differentiation between total and annular eclipses. You can follow the synodic monthly orbit of the Moon, observe a draconic month, and understand the 18-year Saros cycle. Using the model, you'll also gain an understanding of the phases of the Moon. In all, there are 8 different drivetrains within the model. Dates are clearly engraved on the base plate, and the constellations are engraved around the drum. The Earth and Moon are intricately coloured, and the series is completed with an illuminating sun. No specialist tools or any adhesives are required to assemble the model. All you'll need are 1.5, 2, 2.5 and 5 mm Allen keys, sometimes called hex wrenches, and small Phillips head screwdrivers. Do not use Posi-drive or other crosshead screwdriver types. We recommend you use the Tellurion toolkit, which is supplied free to subscription customers. See our website for full details. Unpack all parts carefully and note that some smaller parts are taped to the inside of the packaging. When assembling parts, lay them on a flat table and keep screws and all small items on a saucer or tray so they can't roll away and get lost. Ensure you read all the instructions in the magazines thoroughly when assembling the parts. Look carefully at the parts list and the exploded diagrams before starting each assembly phase. Part numbers in the list are shown on the exploded diagram and all step-by-step assembly diagrams. This video is provided as an introductory guide only. Good luck!
Begin the first phase of Stage 1, the Earth, by using parts supplied with issues 1 and 2. Screw the decorative top nut onto the threaded end of the Earth axis spindle. Slide the Earth axis spindle through planet Earth with the North Pole uppermost against the top nut. Slide one small plastic washer onto the base of the Earth axis spindle to sit below the South Pole. Slide the Earth support arm onto the base of the Earth axis spindle with the projecting inner face of the collar upwards. Slide the spring onto the base of the Earth axis. Slide the small spacer tube over the spring. Slide the second small plastic washer onto the base of the Earth axis spindle. Slide the 18-tooth chamfered gear onto the base of the Earth axis with the chamfered gear teeth uppermost. Secure the assembly by tightening an M3G grub screw into the chamfered gear using a 1.5 mm Allen key. Note that the spring must have space to operate, so leave a small gap at the top of the spacer tube when fixing the chamfered gear. The second phase of stage 1 uses parts supplied with issues 3 and 4. Slide the 54-tooth chamfered gear onto the Earth's support arm so that its teeth mesh with the 18-tooth gear. Slide the long spacer tube onto the Earth's support arm and engage its notches with those in the base of the 54-tooth gear. Slide the 14-tooth chain sprocket onto the Earth's support arm and engage its notches with those in the base of the long spacer tube. Slide the medium plastic washer onto the Earth's support arm. Slide the short spacer tube onto the Earth's support arm. The third phase of stage 1 uses parts supplied with issues 5 and 6. Using a 1.5mm Allen key, thread one M3G grub screw loosely into the side of the spindle collar. Using 3 km 2.5 crosshead screws, fix the 91-tooth gear to the spindle collar. Ensure the screw heads sit in the countersunk sides of the gear. Note that all the crosshead screws used for the model are of the Phillips type, so ensure you use the correct screwdriver. Do not use a posi-drive screwdriver. Slide the 91-tooth gear assembly onto the Earth's support arm so that it is firmly against the previous assembly. Lock the gear in place by tightening the grub screw in the spindle collar using a 1.5mm Allen key. Slide the large plastic washer onto the base of the Earth's support arm. The fourth phase of stage 1 adds the large Earth arm supplied with issue 7. Slot one 8mm steel bearing into the central hole in the top of the large Earth arm. Slot the second bearing into the underside of the same hole. Take the Earth support arm, with all its gears assembled, and slide it through the two bearings in the central hole on the Earth arm, so that the base of the support arm spindle protrudes below. Add the medium plastic washer so that it sits on the protruding lower end of the Earth's support arm. Ensure the lower steel bearing remains in position above the washer. Slide the locking collar onto the end of the Earth's support arm spindle. Tighten the large-headed M3A grub screw into the locking collar using a 2.5mm Allen key. Ensure all the gears and tubes are close-fitting on the spindle above. Now insert the 4 temporary plastic feet into the sockets in the underside of the Earth arm. These provide support for the assembly at this stage, but will be removed later on. Stage 1 is now complete. Begin the first phase of stage 2, the Moon, using parts supplied with issue 8. Take one of the moon pillars, place one 8mm steel bearing over the upper threaded collar. Fix the bearing with one PWM3 crosshead collared screw. Place a second bearing over the lower threaded collar and again fix it with a crosshead collared screw. Insert the base of the moon pillar firmly into one of the 3 half-moon shaped holes around the perimeter of the Earth arm. Secure the pillar with an M3G grub screw using a 1.5mm Allen key. Repeat for the remaining 2 moon pillars and fit them in the remaining 2 horseshoe-shaped holes. Secure each with an M3G grub screw. The second phase of stage 2 adds the solar eclipse gear supplied with issue 9. Place the 159-tooth solar eclipse gear onto the 3 lower steel bearings on the moon pillars. Ensure that the groove around the underside of the solar eclipse gear runs smoothly on the 3 steel bearings. The gear should rotate easily. The third phase of stage 2 adds the moon track supplied with issue 10. Place the moon track over the top tier of the moon pillar bearings and onto the 159 tooth solar eclipse gear. Ensure that the 3 support legs of the moon track sit in the 3 sockets in the top of the 159 tooth solar eclipse gear. The moon track is then tilted at 5 degrees. The fourth phase of stage 2 adds the moon and 161 tooth gear supplied with issues 11 and 12. Take the pre-assembled moon wheel and check that it is pushed firmly onto the angled lower end of the moon axis. The wheel should rotate freely on the inner steel bearing. Slide the top of the moon axis up through the collared hole in the 161 tooth moon gear, ensuring that the collar is uppermost. Now lower the moon gear onto the upper tier of steel bearings on the moon pillars. Locate the moon wheel into the groove in the inclined moon track. Then fit the moon onto the top of the moon axis. The fifth phase of stage 2 adds the midsection supplied with issues 13 and 14. Take the 91 tooth gear and insert the large plastic spindle collar in the centre. Align the countersunk screw holes and secure with 3 KB 2.3 self-tapping screws. Ensure the collar is firm but don't over-tighten the screws. Place the large brass collar over the large plastic spindle collar. At this stage you need to lift off and put aside the moon axis and wheel, the 161 tooth moon gear, the moon's track and the 159 tooth solar eclipse gear. This will enable the 91 tooth gear to be lowered in to mesh with the 91 tooth gear on the Earth drive. Push the central shaft through the large plastic spindle collar and through the earth arm. Ensure the screw hole in the central shaft is at the top. The bottom end of the shaft must lie flush with the underside of the earth arm. Secure the central shaft to the earth arm by inserting the M3G grub screw into the small hole in the side of the earth arm. Tighten the grub screw with a 1.5mm Allen key until the central shaft is locked firmly. The two 91 tooth gears should now mesh. Place the small brass connecting spacer over the top of the large plastic spindle collar. The sixth phase of stage 2 adds parts supplied with issue 15. Slide the 22 tooth gear onto the central shaft, ensuring that the locking jaws are facing upwards. Slide the collared locking spacer onto the central shaft with the widest collar downwards. Engage its 2 jaws in those of the 22 tooth gear below. Slide the medium plastic washer onto the central shaft and seat it on the rim of the collared locking spacer. Slide the 22 tooth chain sprocket onto the central shaft and sit it on the medium plastic washer. It should spin freely on the washer. Slide the connecting brass spacer onto the central shaft and over the top end of the collared locking spacer. Then slide the 23 tooth gear onto the central shaft with its locking jaws downwards. Engage the 2 jaws in those of the collared locking spacer. The 22 tooth and 23 tooth gears should now be able to rotate on the central shaft, locked together. The seventh phase of stage 2 adds the 18 tooth chain sprocket supplied with issue 16. Slide the long brass spacer onto the central shaft so that it sits on the 23 tooth gear fitted previously. Slide the small plastic washer onto the central shaft. Slide the 18 tooth chain sprocket onto the central shaft, ensuring the locking jaws face upwards. Slide the small locking spacer onto the central shaft and engage its jaws with those of the 18-tooth chain sprocket below. The 8th phase of stage 2 adds parts supplied with issue 17. Fix the 24-tooth gear securely to the small plastic spindle collar using 3 KB 2.3 self-tapping screws. Ensure that the locking jaws face downwards. Place the connecting brass spacer over the small plastic spindle collar. Fix the 21-tooth gear securely to the top of the small plastic spindle collar using 3 KB 2.3 self-tapping screws. Slide the 21-tooth and 24-tooth gear sandwich onto the central shaft and engage the jaws with those of the small locking collar below. Secure the entire stack of gears by fixing the PWM8 collared crosshead screw into the top of the central shaft. Ensure the collar of the screw sits on the upper rim of the shaft and does not press against the upper 21-tooth gear. Note, you may need to make a slight adjustment to the height of the central shaft at this stage if the collared screw does not sit correctly. If so, release the grub screw in the earth arm and push the central shaft down or up. The 9th phase of stage 2 adds the pillar support ring supplied with issue 18. The support ring ensures that the 3 moon pillars stand perfectly upright so that the moon gear engages correctly. You will have to temporarily remove one of the moon pillars to fit this collar. First, release the M3G grub screw from the base of the outermost moon pillar. Then, lift out this pillar from the earth arm. Also slacken the grub screw at the base of the 2 remaining pillars, but do not remove these pillars. Next, place the 159-tooth solar eclipse gear back onto the lower bearings of the 2 pillars. Then refit the moon track, ensuring the 3 support legs sit in their sockets. Now place the pillar support ring over the 2 pillars. Refit the 3rd pillar, ensuring its lower bearing slides under the solar eclipse gear. Secure the pillar support ring to the fixing holes in the pillars using 3 km 2.5 countersunk screws. Now, make a visual check to ensure each pillar is precisely vertical. With the centre of the pillar at eye level, compare its upright edge with that of the Earth's central support shaft. Move the pillar left or right until aligned, then tighten the M3G grub screw firmly. Next, refit the moon axis and wheel, and the 161-tooth moon gear, and the moon. Now check that the moon axis travels freely around the moon track so that the moon itself goes up and down through its 5-degree tilted path around the Earth. Stage 2 is now complete. Now begins stage 3, the Sun. The first phase uses parts supplied with issues 19, 20 and 21. To fit many of the parts, you'll need to turn the model upside down or on its side. Therefore, start by temporarily removing all loose parts, the 161-tooth moon gear, the moon, and the moon axis and wheel. Position the central column support collar underneath the large hole in the earth arm with the countersunk screw sockets on the underside. Push the collar through the hole and check the top of the collar is flush with the top surface of the earth arm. Secure the collar with 3 km 2.5 screws in the 3 threaded sockets in the earth arm. Place the 102-tooth gear over the underside of the central column support collar with its countersunk screw sockets on the underside. Secure this gear using 3 km 2.5 screws in the 3 threaded sockets in the collar. Press one 19mm steel bearing into the socket in the top of the central column support collar. Press the second 19mm steel bearing into the socket in the bottom of this collar. The second phase of stage 3 adds the central column and shaft supplied with issues 22, 23 and 24. Remove the short temporary plastic feet from the underside of the earth arm and replace the end two with the new larger feet. Slide the central column through the central column support collar and through the large plastic washer and large brass washer. Ensure that the two pre-fitted 8mm steel bearings remain in the central column at the top and bottom. Slide the central column support onto the base of the central column, making sure that the wide flange is at the base and flush with the bottom of the column and bearing. Secure the support with one large M4G grub screw using a 2mm Allen key. Slide the central shaft through the central column, ensuring the blade end of the shaft is at the bottom. The model can now stand on the two large feet and on the base of the central column support. Push the sun firmly onto the top of the central shaft. This is only a temporary fixture, however, as you'll need to remove the sun again before continuing the assembly. The third phase of stage 3 adds parts supplied with issues 25, 26 and 27. Secure the 91 tooth gear to the large brass collar using 3 km 2.5 countersunk screws. Slide the large plastic washer down the central shaft and over the central column so it sits flat on the top of the 19mm steel bearing in the earth arm. Slide the assembled 91 tooth gear and large brass collar down the central shaft and over the central column so that it sits on the large plastic washer. The 91 tooth gear should also mesh with the 91 tooth gear fitted at stage 2, phase 5. Secure the large brass collar to the central column using an M3G grub screw. Tighten the grub screw with a 1.5mm Allen key. Secure the 160 tooth gear to the small brass collar using 3 km 2.5 countersunk screws. Lift up the model and allow the central shaft to drop down so that its top is below both chain sprockets. Then position the assembled 160 tooth gear and slide the central shaft up through its collar. Lower the model back down again and secure the 160 tooth gear with a grub screw. This 160 tooth gear should also mesh with the 22 tooth gear fitted at stage 2, phase 6. Stage 3 is now complete. The first phase of stage 4 adds the engraved base plate supplied with issue 28. Using a 2mm Allen key, unscrew the M4G grub screw from the central column support and put it aside. Slide the central column support off the base of the central column, ensuring the 19mm steel bearing stays in position. Push the central column support up through the central hole in the engraved base plate, ensuring the engraved details are on the top. Fix the central column support using 3 M3A Allen key screws. Tighten them with a 2.5mm Allen key. The year counter cover plate fits into the rectangular hole in the engraved base plate. Note that this cover plate is not fixed, so it's best to put it aside until the base unit is fully assembled. The second phase of stage 4 adds the engraved drum supplied with issues 29 and 30. Now stand the two drum sections on a firm flat surface, ensuring their engravings are upright. Interlock the flanges to make a complete ring. Lift the assembled model with its engraved base plate and stand it on the assembled drum. The top of the drum should engage into the channel around the outer underside of the base plate. Note that the two drum sections join at Scorpius. The vertical divider line at the end of Scorpius on the top row of symbols must align with 22nd of November on the engraved base plate above. Stage 4 is now complete. Before starting stage 5, we recommend that you lift the earth arm assembly from the large engraved top plate and put this aside. You can then work on the underside of the engraved plate more easily. The first phase of stage 5 adds the year counter, or odometer, and its drive gear assembly supplied with issues 31 and 32. Fix the odometer to the underside of the engraved plate, standing it on the two blocks and securing with 4 long PM3 screws. Check that the drive gear points towards the 4 screw holes in the plate. Now take the pre-assembled odometer gear train and fit the small mount against the small gear. Then add the spacer against the large gear and add the large mount. Align the holes in the mounts with those on the plate and fix with 4 screws for the large mounts and 4 screws for the small mounts. The second phase of stage 5 adds parts supplied with issues 33, 34 and 35. Loosely thread 1 grub screw into the side of one of the spindle collars. Fix the 93 tooth gear to this spindle collar using 3 km 2.5 screws. Loosely thread 1 grub screw into the side of the second spindle collar. Fix the 78 tooth gear to this spindle collar using 3 km 2.5 screws. Fit one of the 8mm steel bearings into the top of the centre support shaft and another bearing in the bottom of the support shaft. Push the centre shaft support down through the outer central hole in the engraved top plate so its top collar sits on top of the plate. Then push the centre shaft with its pre-fitted drive gear up through the shaft support. The gear should now mesh with the gear at the end of the odometer gear train. Slide the 93 tooth gear assembly onto the centre shaft and tighten the grub screw to secure it against the top of the shaft support's collar. Then slide the 78 tooth gear assembly onto the shaft and tighten the grub screw to secure it against the top of the 93 tooth gear. Add the brass spacer and finally the 20 tooth gear with its teeth uppermost and secure the 20 tooth gear with a grub screw. Recheck that the gears are meshed below the engraved top plate and gently rotate the upper gears clockwise, checking that the odometer year digits start to rotate. The third phase of stage 5 adds the Anomalistic month counter parts supplied with issues 36 and 37. Begin by fitting the CM3 crosshead screw into the base of the drive shaft. Fit 1 8mm steel bearing into the top of the drive shaft support and another bearing into the bottom of the support. Then slide the shaft support onto the drive shaft, add the plastic washer and the brass spacer. Fit the 30 tooth gear to the top of the drive shaft and secure it with a grub screw. Secure the eclipse pointer to the top of the drive shaft with the tiny crosshead screw. Insert the Anomalistic month indicator into the hole in the engraved plate aligned with Maius, May. Screw the 3 legs into the underside of the Anomalistic month indicator dial. Finally, stand the legs of the indicator in the sockets on the engraved plate, ensuring the pointer is on top of the dial. The dial can be lifted and rotated to calibrate it when the model is complete. The fourth phase of stage 5 adds parts supplied with issues 38 and 39. Assemble the main drive shaft and gears. Begin by fixing the spindle collar to the 102 tooth gear using 3 km 2.5 screws. Fix the 102 tooth gear assembly to the base of the drive shaft using a grub screw. Note that the collar should be uppermost and the gear at the extreme lower end of the shaft. Add the brass spacer. Insert one 8mm steel bearing into the top of the drive shaft support and another into the bottom of the support. Slide the drive shaft support down through the hole in the engraved plate, aligning with the engraved Augustus. Slide the drive shaft attached to the 102-tooth gear up through the drive shaft support and bearings. Secure the assembly by fixing the 20-tooth gear to the top of the drive shaft using a grub screw. Note that the teeth of the 20-tooth gear should be uppermost and they must mesh with the 93-tooth gear on the centre shaft. Stage 5 is now complete. Stage 6 adds the motor unit and control system. Note that the model can be operated by hand without the motor if you wish. Begin the first phase using parts supplied with issues 40 and 41. Take the bottom base plate. Note that there is a channel around the upper surface perimeter to accommodate the drum sides. The legs fixed to the lower surface, the underside, of the plate. Fix each of the 3 legs to the bottom base plate using 2 M3 Allen key screws. Attach one self-adhesive rubber pad to the foot of each leg. The second phase of stage 6 adds the motor and gearbox supplied with issue 42. Turn the bottom base plate over and stand it on the legs. Lay the rubber pad for the motor's gearbox over the 3 central screw holes in the bottom base plate. Lay the gearbox on the rubber pad and align the 3 fixing holes. Fix the gearbox securely using 3 PM3 screws. Note that the jaws of the gearbox drive shaft should now be exactly central on the base plate. The third phase of stage 6 adds the control system supplied with issue 43. The power and speed controller has 3 pre-wired elements: the speed controller, the on-off reverse switch, and the power inlet socket. Fix the speed controller so that the wires project towards the gearbox. Secure it with 2 PM3 screws, making sure the spindle for the knob goes through the base plate. Fix the power inlet socket with 2 tiny PM2 screws. Push the red plug from the gearbox firmly into the red socket from the speed controller. Push the blue plug from the gearbox firmly into the blue socket from the switch. Turn the base plate assembly over and push the knob firmly onto the protruding spindle of the speed controller. Note that there is a flat face on the spindle which aligns with a flat inner surface in the knob. Also from the underside, fix the switch using 2 KM 2.5 screws. The toggle of the switch should now protrude downwards. At this point in the assembly, the model's drum base can be fixed temporarily to the upper assembly using the 3 bolts supplied with issue 44. The M8 bolts insert from the bottom of the model and must align with the 3 threaded sockets in the underside of the engraved top plate. However, access to the inside of the drum is required for the next stage, so if you intend to continue assembling immediately, do not fix the 3 bolts for now. Stage 6 is now complete. Stage 7 completes the transmission system. Begin the first phase using parts supplied with issues 45 and 46. Begin by lifting the earth arm assembly back onto the large engraved top plate, assuming you removed it at the start of stage 5. Ensure the large plastic washer and large brass washer are still in place on the central column. Lower the central column into the central column support. Check that the plastic and brass washers are a snug fit on top of the central column support. And secure the central column by tightening the support's M4G grub screw. The 102-tooth gear should now mesh with the 20-tooth gear at the top of the year counter central shaft. Turn the model gently onto its side and ensure the 8mm steel bearing is correctly seated in the base of the central column. Slide the long brass locking collar onto the central drive shaft and secure it by tightening the grub screw. Slide the 20-tooth gear onto the central drive shaft so it is firmly against the base of the locking collar. The gear teeth should be uppermost. And secure it by tightening the grub screw. Turn the model upright again, then add the small brass spacer to the central drive shaft. And then the small plastic washer. You can now fit the long chain. With care, this can be done without undoing any of the previous assembly. First, drape the chain over planet Earth and lower it down and around the long chain's sprocket. Now, wrap the chain around the sprocket and pull the chain out below the solar eclipse gear and between the inner two moon pillars. Slide the chain over and around the 22-tooth chain sprocket on the central shaft. Slide the main drive shaft down to its lower limit. You will have to release the grub screws on the locking collar and 20-tooth gear below the engraved gear. Wrap the free end of the long chain around the 14-tooth sprocket and place the sprocket onto the top of the main drive shaft. Finally, slide the drive shaft upwards and retighten the grub screws on the locking collar and 20-tooth gear. Check that the long chain is fully engaged with all teeth on the 22-tooth sprocket and both 14-tooth sprockets. The second phase of Stage 7 adds the short chain and sprocket supplied with issues 47 and 48. Begin by sliding the long brass spacer on the top of the 14-tooth sprocket and engaging its jaws. Wrap the short chain around the 18-tooth sprocket towards the top of the central shaft and pull it taut. Wrap the free end of the short chain around the remaining 14-tooth sprocket. Place the sprocket onto the central drive shaft and engage its jaws with those on the top of the long spacer. Note that you may have to lower the central drive shaft in order to fit this sprocket, as when fitting the long chain. Check that the short chain is fully engaged with the sprocket teeth, then lock the long spacer by tightening its grub screw. The third phase of Stage 7 adds parts supplied with issues 49 and 50. Fit the brass spindle to the 158-tooth gear using 3 km 2.5 screws. Ensure the heads of the screws sit in the countersunk side of the gear. Place the assembled 158-tooth gear on the top of the central drive shaft and ensure it meshes with the 24-tooth gear on the central shaft. Place the date indicator pointer onto the recess at the end of the earth arm with the pointer bending downwards and secure it with one PM3 screw. Now secure the drum base to the engraved plate with the two drum side sections between. This is best done by first turning the upper assembly upside down. Ensure all loose parts are removed first. You'll need to refit them later. Position the two drum sides in the channel in the engraved plate as described previously for Stage 4, Phase 2, noting their correct date alignment. Lay the bottom plate with the motor, control system and legs over the drum sides. Ensure the sides fit in the channel around the outer edge of the bottom plate. Rotate the bottom plate gently until the drive shaft engages with the jaws of the motor spindle. When the 3 bolt holes align with the sockets in the underside of the engraved plate, lower 1 bolt at a time through the bottom plate and engage its thread. Tighten with a 5mm Allen key. Repeat for the other 2 bolts. Then turn the model upright and refit all loose parts, ensuring all gears are meshed and that the year counter cover plate is fitted. Stage 7 is now complete. It's now time to light up and power up. The illuminated sun is supplied with issue 51. Ensure the illuminating sun has batteries fitted and then place it on the top of the 158-tooth gear's spindle. Push down on the sun to light it up and down again to switch it off. The power adapter is supplied with issue 52. Take the mains power adapter and push the small plug into the socket on the underside of the model's base plate. Plug the mains adapter into a suitable mains power supply and switch on. Slide the model's on-off reverse switch to turn the model on. The same switch is used to switch off and to reverse the motion of the model. Stage 8 is now complete and the model should be in full working order. For calibrating and full operational instructions, plus troubleshooting tips, refer to the final issues in the magazine series. Additional tips and frequently asked questions will be available on our website.